ఏం కాదు ఏం ఒక్క నిమిషం. Good evening. Is it audible? Okay, right. So last day we started polar plots. So we solved some problems. So continuation. Draw the polar plot. For g of s, h of s equal to draw the polar plot. S plus 1 by s square into s plus 2 s plus 2. Come on, do it. Draw the polar plot. Come on. Draw the polar plot. Solution. Come on. S replaced by j omega. J omega plus 1 by square into s plus 2 s plus 3. Sorry. J omega whole square by j omega plus 2. J omega plus 3. Then write the magnitude. Root of omega square plus 1 by omega square plus 4 omega square plus 9. Write the phase angle minus 180 plus tan inverse omega minus tan inverse minus tan inverse omega by 3. Next omega 0. First starting direction you tell. Sorry, omega 0. Magnitude infinity. Phase angle minus 180. Omega infinity. Magnitude 0. Phase angle how much? Phase angle, tell, come on. Phase angle how much? Starting direction anti-clockwise, very good. Minus 270, very good. Minus 270. Minus 2. Anti direction clockwise, good, good. So what happens? Here, omega infinity, magnitude 0. Minus 180. Plus 90, minus 90 cancel, minus 270. Omega infinity means each tandem 90, na? So plus 90, minus 90 cancel, then minus 90, minus 180, minus 270. Then here satisfied our condition. Now draw the plot. Now draw the plot. So here starting direction. Starting direction is what? Positive tan is large. Compare omega larger than omega by 2, omega by 3. Omega large means positive tan large. Positive tan large. That means what happened? Direction is what? Anti-clockwise. Ending direction. How many positive tan terms? 1 positive tan term and 2 negative tan terms. So that means negative is more. That means what is the direction? Tell? Clockwise. So initially anti-clockwise and the ending is clockwise. Now draw the plot. Now draw the plot. Come on, this is real axis, imaginary and real. Draw the plot. Draw the plot. This is minus 180. So this is minus 270. Minus 270. Now draw the plot. Draw the plot. So where it starts? Minus 180. Where it ends? Minus 270. But initial direction is, starting direction is anti-clockwise. Start at minus 180. So omega 0, start at minus 180. In the anti-clockwise means downwards, na? That's why I drawn downwards. In case clockwise, I will draw upward. So initial anti-clockwise. So it move in anti-clockwise direction like this. It move in anti-clockwise direction. Anti-clockwise direction. Then what happened? End in a what? Clockwise direction. That means what happened? It cannot go continuously in this way. If you go like this and end, where it should be end? Here it should be end. It should be end at minus 270. If you go like this, then the plot should be intersect minus 90, 0 degrees as well as minus 270 degrees. And moreover, the total plot direction become anti-clockwise. If you go like this, complete plot direction is anti-clockwise direction. This total become anti-clockwise, but ending direction is clockwise. That means what happened? And moreover, you find intersection point with minus 90, you don't get the intersection point with minus 90. You don't get the intersection point with minus 90. It don't get intersection point. That means the plot should not intersect the what? Minus 90. So initially it move in anti-clockwise direction, and it should not intersect minus 90. It should not intersect 0. If you find also, you don't get it. So then that's why it should not intersect minus 90. Then what is the next alternative? And direction also should be changed. So it will intersect the minus 180 degrees. And now direction is changed. What is the direction? Tell here. And this is starting direction, anti-clockwise. This is ending direction, clockwise. Then where it should be end? Minus 270. Where it should be end? Minus 270. Where it should end? Minus 270. Here omega equal to infinity. Omega equal to infinity. Okay, na? So like this, you have to draw the plot. And now you find intersection point with minus 180. If our answer is correct, then you will get the intersection point with minus 180. If our answer is wrong, then omega, you will get the imaginary. Omega imaginary we are getting, then our answer is wrong. Our answer is wrong. If omega is real, then our answer is correct. So in case omega imaginary we are getting, in case omega imaginary, you don't get it. In case, some rare cases, in case anywhere intersection point is invalid, then you draw the plot simply by using ending direction. Simply by using ending direction. In case invalid intersection point occurs, then draw the plot completely by using only ending direction. But that won't occur, no doubt. Come on, check the intersection point. Intersection point with imaginary. Intersection point with minus 180 degrees. Intersection point with minus 180 degrees. Come on, find the intersection point with minus 180. Come on, find it. Angle GH equal to minus 180. So minus 180 equal to minus 180 equal to minus 180 plus tan inverse omega minus tan inverse of omega by 2 minus tan inverse of omega by 3. Now 180 cancelled. Now minus tan inverse omega equal to minus tan inverse omega by 2 minus tan inverse omega by 3. All minus become plus. Tan inverse of omega equal to tan inverse of omega by 2 plus omega by 3 divided by 1 minus omega square by 6. Tan cancel. Omega equal to 5. LCM what? 6 na? 5 omega divided by 6. Yes or no? 3 omega, 2 omega. LCM 6. 5 omega by 6 divided by 6 minus omega square divided by 6. 6 cancel. Then omega equal to 5 omega by 6 minus omega square. Omega cancel. 6 minus omega square equal to 5. Omega equal to 1. So 1 radian per second. So omega 1, it is a real, na? It is a real. Yes or no? It is a real value. So omega equal to 1. So minus omega square equal to what, man? Minus omega square equal to minus 1. So omega equal to 1. So minus become plus. Omega is 1. It is a real part. It is a valid intersection point. Valid intersection point. If you have any doubt, you substitute here omega 1. You will get exactly minus 180. You substitute here omega 1. If you substitute omega 1, what happened? Plus 45, you will get this. This is plus 45. This is minus 26.57. This is minus 18.43. So these two become minus 45. Minus 45 plus 45. Both will cancel. Then you will get the what? Exact value of what? Minus 180 degrees. So that means omega 1 is a correct answer. Omega equal to 1 is a correct answer. So that means at this point, omega equal to 1. Omega equal to 1 radian per second. So now at this value, you want to find angle, the angle become exactly minus 180 degrees. That means our plot is correct. Not only that, you take any value of omega greater than 0, less than 1. You take any value of omega greater than 0 and less than 1, greater than 0 and less than 1. Then the angle is less negative than minus 180 degrees. The angle is less negative than minus 180 degrees. If omega greater than 0, less than 1, the angle is less negative than minus 180 degrees. If omega greater than 1, the angle is more negative than minus 180 degrees. More negative than minus 180 degrees. If omega greater than 1, the angle become more negative than minus 180 degrees. If omega less than 1, the angle is less negative than minus 180 degrees, equal to 1 minus. Why? Because omega less than 1 means the positive tan value dominates. Compared to these two negative values, positive tan value is more. You take any value of omega between 0 to 1. For example, you take omega 0.5. Check the value of positive tan and negative tans. Positive tan value larger than sum of these two negative angles. Sum of these two negative angles. At omega equal to 1, positive tan value equal to sum of these two negative tan values. Omega greater than 1, these negative tan values are more than the what? Positive tan. That's why again it pushed into the what? Clockwise direction. So initially it moved in anti-clockwise, then finally it moved in a clockwise direction. Whenever starting ending directions are different generally, so you will get the middle intersection point around that axis. Generally will get the middle intersection point around that axis. Okay, na? Next. Got it, na? This is the next problem. Next problem. Similarly, solve the one more problem. Solve one more problem similarly. Come on. GH of S equal to S plus 3 by S square into S plus 1 into S plus 2. Come on, do it. Come on, do it. Yes, starting ending directions are 0.5. Clockwise, correct. We can find here magnitude also. In this case, you can find magnitude, but it is not required. That's why I didn't find it. Okay. Now, come on, solve it. S replaced by j omega. Come on, you do it. GH of j omega equal to j omega plus 3 divided by j omega whole square into j omega plus 1, j omega plus 2. Then magnitude. Root of omega square plus 9 by omega square. Root of omega square plus 1. Root of omega square plus 4. Page angle pi. Minus 180 minus tan inverse omega minus tan inverse omega by 2 plus tan inverse omega by 3. Omega 0, magnitude infinity, angle minus 180. Omega infinity 0, angle minus 270. Now, starting direction, negative tan, so clockwise. Ending direction, so 2 negative and 1 positive, then clockwise. So both are clockwise direction. So like this. So minus 180 starts, move in clockwise, omega 0, move in clockwise, end at minus 270. Clockwise, omega infinity. So this is the clockwise direction. Okay, na? Like this, you have to draw the plot. Okay. So here, if you have any doubt, check the intersection point. Come on, check the all of intersection points. See, for example, in the exam, they given this question. For example, they asked this question in the exam. One option is this given. Another option given like this, for example, because we are not finding middle values now. Another option, for example, given like this, omega 0. Another option like this given. This is the one more option, for example. This is the another option given. Then which is correct? Tell. Here also starting direction clockwise. Here also ending direction clockwise. Then how can you select the answer which is correct? How can you select the answer which is correct? So we need to find the what? We need to check the what? Intersection point with minus 180 degrees. Check the intersection point with minus 180 degrees. Come on, check it. Check the intersection point with minus 180. Intersection point with minus 180 degrees. Intersection point with minus 180 degrees. Come on, angle GH equal to minus 180. Come on, Guruji. Minus 180 equal to minus 180 minus tan inverse omega minus tan inverse omega by 2 minus tan inverse omega by 2 plus tan inverse omega by 3 plus tan inverse omega by 3 omega by 3. 180 180 cancel, 180 180 cancel. Then this come to left side, minus tan inverse of omega by 3 is equal to minus tan inverse omega minus tan inverse of omega by 2 minus tan inverse omega by 2. Now solve it, all minus becomes the plus. So tan inverse of omega by 3 equal to tan inverse of omega plus omega by 2 divided by 1 minus omega square by 2. 1 minus omega square by 2. Tan cancelled. Tan cancelled. Then what happened? Omega by 3 equal to 3 omega divided by 2 minus omega square. Omega cancelled. 2 minus omega square equal to 9. So minus omega square equal to 7. So omega equal to what? Plus or minus j root 7. So imaginary invalid point. Imaginary invalid intersection point. Invalid intersection point. Type intersection point. Invalid intersection point. That's all. Invalid intersection point. So that means what happened? This is wrong. This is correct. This is correct. We can, whenever omega is imaginary means it is an invalid intersection point. We remember. Omega imaginary means invalid intersection point. Be remember. Okay, na? Omega imaginary means invalid intersection point. Invalid intersection point. Invalid intersection point. In this case, we can draw plot just by using the what ending direction. In this case, draw the plot by using simply ending direction. Draw the plot by using ending direction. In case starting direction and ending direction both are different, and imaginary you are getting, that means it is an invalid intersection point. So by using ending direction. In this case, draw the plot by using only ending direction. That's all. Okay, na? If starting ending directions are different. So in this case, draw the plot by using ending direction. Enough. Even or if starting ending directions are different, if starting and ending directions are different, and intersection point is imaginary. Intersection point is imaginary. In the bracket, invalid point. In the bracket, invalid point. So intersection point is imaginary, in the bracket invalid point. Then draw the plot by using ending direction only. You have to check it always, intersection point with imaginary. Always, whenever plot is starting ending directions are different, automatically intersect the middle point. That intersection point compulsory you have to check it. That intersection point omega real, valid. Omega imaginary, invalid. Invalid means then don't consider starting direction. Simply draw by using the what? Ending direction. That's all. Next problem. Come on, solve this. Come on, S plus 1. But that cases, it won't occur, no doubt. It won't occur that in case anywhere, any question, very tough question gives, then you be careful. Come on, do it. Right. Write it. Solution. G of S, H of S replaced by J omega. GH of J omega equal to J omega plus 1. J omega plus 2. j omega plus 3. Magnitude omega square plus 1. Omega square plus 4. Omega square. Phase minus 180 plus tan inverse omega. Plus tan inverse plus tan inverse omega plus tan inverse omega by 2 minus tan inverse omega by 3. Come on, do it. Omega 0, magnitude infinity, angle minus 180. Omega infinity 0. What is the angle? Tell. This plus 180 minus 180 0. That means minus 90. Satisfied our direction. Satisfied our condition. Satisfied our condition. Now do it. Come on. Starting direction. Positive tan. Anti-clockwise. Ending direction also 2 positive and 1 negative. So that means anti-clockwise. Come on, draw the plot. Both are anti-clockwise. So no intersection point. If you want to find in your O. So starts at where? Omega 0, moving anti-clockwise. End at what? Minus 90 here. Omega infinity. End at minus 90 like this. So both the directions are what? Anti-clockwise. Both are same. So like this you have to do. One more problem, you solve it. One more problem. Come on. Next problem, come on, solve it. S plus 2, S plus 3 by S square into S plus 1. Come on, do it, bhaiya. Do it. Jaldi, jaldi karo. Come on. S replaced by j omega. GH of j omega equal to j omega plus 2. J omega plus 3. J omega whole square. J omega plus 1. Magnitude root of omega square plus 4. Root of omega square plus 9. Omega square. Omega square plus 1. Phase minus 180. Minus tan inverse omega. Plus tan inverse omega by 2. Plus tan inverse omega by 3. Bolo omega 0. Magnitude infinity. Phase angle tell minus 180. Omega infinity. And magnitude 0. Bolo, what you will get? Come on. Minus 180 minus 270 minus 90. Satisfied our condition. Next, starting direction. Negative tan. Clockwise. Ending direction. 1 negative and 2 positive. So that means what happened? 1 negative, 2 positive. That means it is anti-clockwise. 2 positive, na? Anti-clockwise. Then draw the plot. Draw the plot. So what happened here? Where it starts, minus 180. Where it ends, minus 90. Now what is the direction? Initial direction, clockwise. 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 Where it should be end? Minus 90. Initial direction, clockwise. Clockwise means up only, na? So this is the clockwise. Ending direction is minus 90. That means it will come like this. What is this? Clockwise. This is anti-clockwise. Starting direction is clockwise. Ending direction is anti-clockwise. You want to find intersection point. You do in your home, you'll get omega 1 only. You find intersection point here, you'll get omega 1 radian only. You can check by yourself. Okay, na? So like this, you have to draw it when there is a finite poles and finite zeros. Okay, na? Next, I'll take poles and zeros in the right side. First, I'll take G of S, H of S equal to 4 problems. I'll take G of S, H of S equal to 1 by S into S plus 1. G of S, H of S equal to 1 by S into S minus 1. G of S, H of S equal to 1 by S into minus S minus 1. G of S, H of S equal to 1 by S into 1 minus S. Come on, solve these 4 problems. First solve this. First one already one solved. Again solve it. Come on. Do it. All these 4 problems having same magnitude. For example, what is the magnitude for all these 4 problems? 1 by S into minus S minus 1. 1 by S into 1 minus S. For all these 4 problems, 1, 2, 3, 4. What is the magnitude? Tell. Same. 1 by omega root of omega square plus 1 only. The magnitude is same. There is no difference. The difference is only phase angle. The magnitude is same. The difference is only in the phase angle. Come on, do it. No need to write magnitude, write the phase. Come on. Right. What is the phase angle? Tell. Phase equal to S replaced by J omega. Not required. Directly can write the phase. S replaced by J omega. GH of J omega equal to 1 by j omega into j omega plus 1. Write the phase angle. Minus 90 minus tan inverse of omega. Minus 90 minus tan inverse of omega. What is the direction? Clockwise. The direction is clockwise. Direction is clockwise. Next, omega 0. Only one tan term, na, directly we can write the direction. Omega infinity, 0, magnitude infinity, phase angle minus 90. Omega infinity 0, angle minus 180. Satisfied condition. Now draw the plot. Where it starts minus 90. Where it ends minus 180. So what is the direction? Omega 0. So this is the direction. This is clockwise. Omega infinity. Next, S replaced by j omega. GH of j omega equal to 1 by j omega. J omega minus 1. Write the magnitude. Magnitude not required. Directly write the phase. Write the phase angle. Omega 0 means infinity only, no magnitude. Omega 0 means S0, that's all. Angle minus 90. Which coordinate it is? I told already. Negative real. Minus 1 means negative real. And plus j omega means positive imaginary. Negative real, positive imaginary. Negative real, positive imaginary. What is the angle? 180 minus theta. That means what I should write? Minus of, because pole it is minus. 180 minus tan inverse of imaginary part omega, real part 1. You should not include the sign. Sign should not include. Real part 1. Sign should not include. That means what is the pi? Minus 270 plus tan inverse omega. Only one tan term, positive tan. What is the direction? Anti-clockwise. Omega 0 infinity. Angle minus 270. Omega infinity 0. Angle minus 180. So satisfied our condition. Draw the plot. Draw the plot. Come on, where it starts? Minus 270. Where it ends? Minus 180. What is the direction? Anti-clockwise. Draw the anti-clockwise plot. This is a what? Anti-clockwise. Only one tan term means what? No need to do the starting and ending direction. When there are positive and negative tan terms, then you have to go for starting and ending. Only one tan term, directly we can write the direction. Next, third problem, solve it. Come on, third and fourth you solve. Third and fourth you solve it, man. Come on. Come on, today we have to close this chapter. S replaced by j omega. So, GH of j omega equal to 1 by j omega into minus j omega minus 1. Phase angle pi minus 90. Negative real. Minus 1 means negative real. Minus j omega means negative imaginary. So negative real, negative imaginary. Then what is the angle here to here? 180. So more than 180 here. So that means angle is 180 plus theta. So that means minus 90 minus of 180 plus tan inverse of omega. 180 plus tan inverse of omega. That equal to minus 270 minus tan inverse omega. What is that here? Clockwise. Omega 0 infinity minus 270 omega infinity 0 minus 360. Come on, draw the plot. Where it starts? Minus 270. Where it end? Minus 360. What is the direction? Omega 0. Here ending. What is the direction? Clockwise. Here omega infinity. Next, come on, fourth problem. S replaced by j omega. Gh of j omega equal to 1 by j omega into 1 minus j omega. Pi minus 90 minus of which region it is? Positive real, negative imaginary. That means simply minus theta. Fourth region. Minus theta. Minus of what? Tan inverse of omega. So that means minus 90 plus tan inverse omega. So that means what is the direction? Anti-clockwise. Omega 0 infinity minus 90. Omega infinity 0 degrees. Satisfied condition because plus 90 minus 90 0. Now draw the plot. Where it starts minus 90. Where it ends 0. What is the direction? Anti-clockwise. Omega 0 anti-clockwise. And if you now observe these four plots, no two plots are same. Even according to pole location, if you see, first one equal to third one. According to pole location, what is the pole location? 0 and minus 1. What is the pole location here? 0 and minus 1. But the plot will be different. Why? Because there exists a 180 degrees phase shift between first and third. Second and fourth also 180 degrees phase shift is there. So you should be perfect in writing phase angle. That's all. Automatically you will get the answer. Omega 0 means just substitute S0. Omega infinity means just substitute S infinity. You will get the answer. No need to worry. But you should be perfect in writing the what? Phase angles. You should be perfect in writing the phase angles. Okay, na? So you write the correct. If you are perfect in writing the phase angles, then you can draw the correct polar plot. Okay? Next problem. GH of S equal to, come on, solve it. S minus 3 by S into S plus 1. Come on, do it. S replaced by j omega. GH of j omega equal to j omega minus 3 divided by j omega into j omega plus 1. Come on, write the magnitude. Root of omega square plus 9 by omega root of omega square plus 1. Come on, do it. Come on, Bhaiya, come on. Phase angle minus 90 minus tan inverse omega plus 180 minus tan in second coordinate na 180 minus tan inverse omega by 3. Now simplify this. 90 minus tan inverse omega minus tan inverse of omega by 3. Omega 0 infinity plus 90. Omega infinity minus 90. Satisfied our condition. Now draw the plot. What is the direction? Both are negative means clockwise direction. Come on, draw the plot. Where it starts? Plus 90. Where it ends? Minus 90. What is the direction? Clockwise. Omega 0. Omega infinity. So clockwise direction. Next. G of s, h of s equal to s plus 2 by s plus 1, s minus 1. Come on, do it. Come on. S replaced by j omega. S replaced by j omega. GH of j omega equal to j omega plus 2 by j omega plus 1, j omega minus 1. Then write the magnitude. Root of omega square plus 4 by omega square plus 1. Write the phase angle. Minus tan inverse omega minus of 180 minus the second coordinate na 180 minus tan inverse omega plus tan inverse of omega by 2. What is the answer? minus 180 here, minus plus, and this to get the cancel. Minus 180 plus tan inverse of omega by 2. What is the direction? Anti-clockwise. Omega 0. Omega 0. Magnitude 2. Phase angle minus 180. Omega infinity 0. Minus 90. That's all. Draw the plot. Draw the plot. Minus 180 starting. Ending minus 90. Magnitude 2 here. End at minus 90. With the magnitude of 0. What is the direction? Anti-clockwise. Omega 0. That's all. Next, one more problem. Come on, solve it. Do it. GH of S equal to S plus 2 by S minus 2. Come on, do it. S plus 2 by S minus 2. Karo Guruji, karo. Come on, do it. What is the magnitude? Yes, correct. One way it is all pass filter. Come on, do it. Magnitude 1, very good. Write the phase angle. Magnitude 1, correct. Phase angle you write. Write the phase. And do it. Magnitude is 1. Phase angle you write. S is called J omega na. S replaced by J omega. GH of J omega equal to J omega plus 2 by J omega minus 2. Magnitude 1. Phase equal to tan inverse omega by 2 for numerator. Denominator second quadrant. So 180 minus tan inverse of omega by 2. That equal to below minus 180 plus 2 times of. This also become plus here plus 2 tan inverse of omega by 2. Direction anti-clockwise. Omega 0 1 minus 180. Omega infinity 1 0 degrees. Satisfied our condition. Equal to also satisfied. And now draw the plot. Where it starts? Minus 180. Where it end? 0 degrees. What is the magnitude? 1. Omega 0. What is the magnitude? 1. Omega infinity. Now draw the direction. Anti-clockwise. That's all. Next, exponential term. Next, we'll do for exponential term. Next one, exponential term. Come on, do it. e power minus s by s into s plus 1. Don't expand the exponential term. Don't expand the exponential term. Because when there is a standard procedure, you should not go by approximated. When there is a standard procedure, never go by approximated. Come on. Listen. S replaced by j omega. So gh of j omega equal to e power minus j omega by j omega into j omega plus 1. Magnitude 1 by omega root of omega square plus 1. Write the phase angle. Minus 90 minus tan inverse omega minus e power j theta angle theta na, e power minus j theta means minus theta minus omega, but omega in radians. Convert into degree by producting 180 by pi. Convert into degrees by producting 180 by pi. 180 by pi. This is the phase angle. Now, this angle is not a finite angle. Omega infinity means this angle become infinity. That's why you have to go by standard procedure. You have to go by standard procedure. Do the standard procedure. Omega, magnitude, phase, 0, 1, 2, 5, 10, infinity. Omega 0, infinity. Angle minus 90. Omega 1. Magnitude how much? 0.707. Angle omega 1 is substitute here. The angle will get minus 192. The angle minus 192. Next omega 2. Omega 2 means 0.22. The angle minus 267. Because omega infinity means this will become infinity, then we cannot identify how the plot you are getting. That's why you have to go by standard procedure. Omega 5, 0.04 minus 455. But till now they didn't ask any question on exponential term. They don't ask also. Because we require to calculate. Then minus 747. Infinity 0. Then minus infinity. Now draw the plot. What you observed here, at the frequency increasing, omega increasing, magnitude is go on decrease. Magnitude is decreasing. But phase is increased to minus infinity. Phases are decreased to minus infinity. Phase is decreased to minus infinity. Go on reduced to minus infinity. Now draw the plot. How the plot is? Draw the plot. It starts at minus 90. Come on, draw the plot. Starts at minus 90, omega 0. Then what happened? Omega 1. This is minus 180. Omega 1. What happened? Magnitude 0.707. Angle is minus 192. And it goes to minus 192. Somewhere here, consider 192. 192, you consider here. Magnitude of 0.707. This magnitude infinity. Next, omega 2. 0.22. Angle minus 267 means it is increased a little bit. So here minus 267 you consider magnitude 0.22. Next what happened? 270. Next angle what? 455. This is 270. Then 360. Then 450. Then 455 here. Magnitude 0.04. Like this. Go on. Angle what happened? Go on increasing. 450. Next what happened? 540. 630. Like this. Angle go on increase. Magnitude go on decrease. Angle go on increase. Magnitude go on decrease. Finally, somewhere, wherever you want to make it 0. Because infinite angle means wherever you want, you can make it 0. Infinite angle means wherever you want to make it 0. Like this, you will get it. This is a polar plot for what? E power minus s by s into s plus 1. They don't ask it. But if you ask, you have to solve like this. Be remember. Okay, na? Next problem. Draw for this. G of s, h of s equal to pi into e power minus 2s. Come on, do it. Karthik. Karthik. Right. Do it, man. Right. Okay. Next. Do this problem. Pi into e power minus 2s. What is the answer? Come on, do it. So the magnitude s replaced by j omega. So gh of j omega equal to pi into e power minus 2j omega. Magnitude is pi. Phase angle is minus 2 omega. It is in radians. Product with 180 by pi. Minus 2 omega. Product with 180 by pi. 180 by pi. Now omega 0. Magnitude pi. Angle 0 degrees. You have to go by procedure. Na? Write the tabular form. No problem. Omega. Magnitude. Phase. Omega 0. Magnitude pi. Angle 0 degrees. Omega. Pi by. You can take omega pi by 4. Magnitude pi only. Magnitude pi. Phase angle bolo. Pi by 4 means here substitute pi by 4. Pi by 4 means pi cancel. Pi by 2. So I think minus 90 degrees. Next pi by 2. Magnitude pi. Come on. Pi by 2 substitute 2 to cancel. Pi cancel. That means minus 180. Next, come on. 3 pi by 4. Like this, go on, substitute. Magnitude always constant only. There is no change in magnitude. There is no change in magnitude. Here, 3 pi by 4. Next, pi. Here also pi. Here what happened? Minus 360. Like this, go on, continue. As the magnitude is constant, the path is same. As the magnitude is constant, it starts at 0 degrees. Magnitude of pi, omega 0, minus 90, magnitude here pi, here minus 180, magnitude pi, like this. Wherever, like this. So you'll get a circle with a radius of pi. You'll get a circle with a radius of pi, like this. You'll get a circle with the radius of pi. Circle with a radius of pi. This is the diagram, 0. So circle with the radius of pi. Okay, na? Because this will go on rotate minus 270, minus 360, like this again continued. Wherever you observe, the magnitude is pi only. The magnitude is pi only. It is a circle. Next problem. Completed? Correct. Circle with the radius of pi. Next, identify the stability to the given polar plots. Identify the stability. Identify the stability to the given polar plots. To given polar plots. Come on, draw it. Right. Right. Okay. Right. Now identify the stability. I'll draw the polar plot. Listen. I'll draw the polar plot. Unit circle. This is called unit circle. Polar plot also gives the stability of only minimum phase system. It cannot give a stability of non-minimum. Non-minimum given by only Nyquist plots. Non-minimum given by Nyquist plots. Come on, do it. First problem. First, second. This is third. Right, come on. This is magnitude 1. Come on, do it. Solve it. First problem. Come on. See, the frequency at which the phase angle is minus 180 degrees is called phase crossover frequency. This is called phase crossover frequency. The frequency at which the phase angle is minus 180 degrees is called phase crossover frequency. This one. Next, the frequency at which unit circle means magnitude 1. The frequency at which magnitude is equal to 1 is called gain crossover frequency, omega GC. This is omega GC. Which is greater, tell? Omega GC or omega PC? Here omega 0. Don't see the magnitude. Don't see the magnitude. Here magnitude equal to 1, here less than 1. Don't say this is greater. See the frequency. Here omega 0, least frequency. But magnitude infinity, you should not see the magnitude. Least frequency, 0 here. 0, go on increasing. Maybe here 100. Here maybe 1000. Here infinity. 0, 100, 1000, infinity. Which is greater? 1000 greater than what? 100. That means omega PC greater than omega GC. The closed loop system is stable. The closed loop system is stable. But the starting angle should be either it should be start at 0 degrees or minus 90. Why? Because here we are using gain margin, phase margin concept, means this is valid for only minimum phase system. All these plots of what? Minimum phase systems only. So that's why I'm going for unit circle drawn, means generally it should be drawn by using the what? Gain margin, phase margin concept. So omega PC greater than omega GC, the system is stable. Now find the gain margin and phase margin. For example, in the exam, they'll give the intersection point and angle. For example, here you consider they given this is minus point. They will give in the exam. This is minus 0.5 for example. And in case this angle is, for example, this angle is, for example, you consider this angle is right. This angle. For they will give the angle also in the exam. For example, this is minus 120 degrees. Then they will ask what is the gain margin and phase margin. So what is the magnitude at omega PC tell? What is the intersection point minus 0.5 means what is the magnitude? Magnitude at omega PC equal to 0.5. Magnitude at omega PC 0.5. So gain margin is, what is the formula? Gain margin in linear scale 1 by magnitude at omega PC in linear scale. In dB means minus 20 log magnitude at omega PC. In linear scale 1 by magnitude at omega PC. That equal to 1 by 0.5. 1 by 0.5 that equal to 2. 2 in linear. In dB want gain margin in dB want. So minus 20 log 0.5. Minus 20 log magnitude at omega PC is 0.5. You solve it. Minus 20 log 0.5. You solve it. 0.5 equal to plus 6 dB. Plus 6 dB. So that means positive. This is in dB. This is in linear. Similarly, find the phase margin. Pi at omega GC, how much tell? Pi at omega GC. Pi at omega GC. This is omega GC only, na? Pi at omega with respect to 0 degrees you have to consider. That is minus 120 degrees. Pi at omega GC minus 120 degrees. Then what is the phase margin formula? 180 plus pi at omega GC. Pi at omega GC. That means 180 minus 120 degrees. That equal to plus 60 degrees. That equal to plus 60 degrees. Plus 60 degrees. That's all. That equal to plus 60. Both are positive. Both are positive. Closed loop system is stable. Both are positive. Closed loop system is stable. That's all. Both are positive. Closed loop system is stable. Okay, na? That's all. Next. Come on. Here at this point, what? At this point, come on. Omega PC equal to omega GC. At this point, omega PC equal to omega GC. Omega PC equal to omega GC. That means marginal stable system. Omega PC equal to omega GC means closed loop system marginal stable. Closed loop system is marginal stable. And now tell, what is the magnitude here? 1 na? Magnitude is 1 here. Gain margin tell, magnitude at omega PC equal to 1. Gain margin 1 by magnitude at omega PC na ante 1 by 1. Equal to 1 in linear. Equal to 1 means it is marginal stable. Greater than 1 means stable. Greater than 1 means stable. Greater than 1 stable. Equal to 1 means marginal stable. Marginal stable. Even in dB want. So simply 20 log 1 or minus 20 log magnitude at omega PC is 1. That means 0 dB. So magnitude is, gain margin is 0 dB. Means marginal stable. Even phase margin if you write. What is this angle tell? Minus 180. Minus 180. Angle is minus 180. Pi at omega GC equal to minus 180. Minus 180. Phase margin. So 180 plus pi at omega GC. Pi at omega GC. So that means what? 180 minus 180. Then what happened? Equal to 0 degrees. System is what? Marginal stable. Never take this angle in anti-clockwise direction. The angle should be considered only in the clockwise direction. When you are calculating gain margin, phase margins, the angle should be considered only in the clockwise direction. Never consider anti-clockwise direction. Okay? Next problem. Come on, solve this. Come on, for example here, is it stable or unstable? This is what omega PC. This is what omega GC. Which is greater? Here omega 0, 1000, 10,000. Which is 10,000? Omega GC. That means omega PC less than omega GC. The closed loop system is unstable. The closed loop system is unstable. The closed loop system is unstable. Now tell. The closed loop system is unstable. Now tell, for example, I'll take this is -2. This is -2, I'll take for example. This angle is, for example, -250 I consider. This angle is -250 I consider. -250. Come on, get the answer. Magnitude at omega PC. Magnitude at omega PC equal to 2 in linear. Magnitude at omega PC equal to 2 in linear. Gain margin. So 1/2 means 0.5 less than 1. Less than linear. Linear is 0.5. This is in linear. Less than 1 means generally what happen? Unstable. Less than 1 means generally unstable. In dB want to find -20 log. Magnitude at omega PC how much? 2. -20 log to -6 dB unstable. Pi at omega GC -250 degrees. -250 degrees. Then phase margin 180 -250 -70 degrees. -70 degrees. Both are negative. Closed loop system is unstable. Closed loop system is unstable. That's all. Like this, you have to find the stability. Like this, you have to find the stability. Next. So that means what to understand in about 3 problems? About 3 problems, what you understand? Whenever the polar plot intersect -180 degrees line with a magnitude less than 1, with a magnitude less than 1, whenever polar plot intersect -180 degrees line with a magnitude less than 1, closed loop system stable. Whenever polar plot intersect -180 degrees line exactly magnitude 1, then closed loop system marginal stable. Whenever the polar plot intersect -180 degrees line with a magnitude greater than 1, the closed loop system is what? Unstable. Greater than 1 unstable, less than 1 stable, equal to 1 marginal stable. So what is the conclusion? Whenever polar plot intersect, next page I'll write. Whenever the polar plot intersect -180 degrees line with a magnitude, whenever polar plot intersect -180 degrees line with a magnitude less than 1, with a magnitude less than 1, then the system is stable. Then the closed loop system is stable. Then the closed loop system is stable because here omega PC, because here omega PC greater than omega GC. Whenever polar plot intersect, -180 degrees line, -180 degrees line with a magnitude equal to 1, with a magnitude equal to 1, then closed loop system is marginal stable. Then closed loop system is marginal stable because here omega PC equal to omega GC. Whenever the polar plot intersect, minus 180 degrees line with a magnitude greater than 1, then closed loop system unstable. Because here omega PC less than omega GC. That's all. So be remember this. Okay, na? Next. See, and simply what do you understand? Less than 1 stable, equal to 1 marginal stable, greater than 1 unstable. That means easily we can identify the relative stability even in the polar plot by observing the intersection point with minus 180 degrees. For example, if you see, I'll draw like this. This is 1. This is 2. This is 3. So which is more stable here? Tell. All these omega zeros. Below this is 1. This is 2. This is 3. This is 4. Which is more relative stable here? Which is more relative stable? Come on. Which is more relative stable? 1. Very good. 1 is more relative stable. As the intersection point moves towards minus infinity, less relative stable, more oscillatory. Less relative stable, more oscillatory. As it moves towards minus infinity. 1 is more relative stable. Okay, na? As the intersection point moves towards minus infinity, with minus 180 degrees as the polar plot, as the intersection point with minus 180 degrees moves towards minus infinity, then system less relative stable. All these statements valid for only minimum phase systems. Above all statements valid for only minimum phase systems. All above statements valid only for minimum phase system. That's all. Okay, na? Right. Minimum phase system how to find means it should be starting angle should be either 0 or maximum minus 90. That's all. The starting angle should be 0 or minus 90. Then it is called a minimum phase system. starts at minus 180 means minimum 2 zeros at origin or pole in the right. That means it is not a minimum phase system. That's all. Minimum phase system is a stable. All the finite pole, finite zeros lies left. Maximum allowable number of poles is only one pole at origin. Okay. Next problem. What is the condition for stability? The magnitude should be less than 1. Then only system is stable. Note on one problem. For the polar plot shown in figure, for the polar plot, shown in figure, find the range of k value. Range of k value for stability. For closed loop stability. Come on, do it. Minus 0.01 k. Come on, do it. What is the condition for stability? For closed loop stability, magnitude less than 1. So that means 0.01 k minus 0.01 k. Yes or no? For closed loop stability, magnitude less than 1 with minus 180 na? This is minus 180 only na? Magnitude should be less than 1. So minus 0.01 k less than 1. K is what? Less than 100. Default greater than 0. By default greater than 0. So 0 to 100, the system is stable. Next, one more problem. For the polar plot, for k equal to 10 is shown in figure. Is shown in figure. The range of k value for system stability is. The range of k value for closed loop stability is. Draw the plot. Come on, do it. So what happened here? Listen, this is the polar plot for k equal to 10. Anybody answer? Right. Generally, gain margin, phase margins are having same sign. One is positive, one is negative. Generally, we don't get. In case unless until you calculate wrong, or if by mistake if you calculate for the what non-minimum phase systems, you may get it. Generally, for minimum phase systems, both are having same sign. Both are having same sign for minimum phase. Non-minimum phase system, if case calculate, but it should not write the stability. Stability is, when it is stable means both should be positive, then only stable. One is positive, one is negative, it is unstable only. Okay. Come on. What is the answer? So here, how to find range of K? K is not included in the intersection point. Whenever K is not included in the intersection point, you should product with K that intersection point. Product with K divided by given K value. What is the K value given? 10. You should product with K divided by given K value. That indicates what you know. That indicates what you know. If I substitute K10, we will get the same intersection point. If substitute K10, for example, here K10 substitute same intersection point should not change. So whenever intersection point not include K, product with K and divided by K value. Whenever intersection point not includes K, then product intersection point with K, product the intersection point with K and divide with given K value. Divide with given K value. Given K value. That's all. So that means what is the answer? Now for stability, for closed loop stability, minus of 0.01 K by 10 should be less than 1. K is less than 1000, greater than 0. That's the answer. Closed loop gesture stability. That's all. Okay, like this you have to solve it. One more shortcut method problem is there. Actually, that is not a minimum phase system, but one simple shortcut method is there that I'll tell after the break. Take the 10 minutes break. Sri Charan.
Sir.
Tell, jaldi, fast.
Sir, in e power j omega problems, we can't derive polar plot by shortcut method, sir. Omega called
no. I told no, it is infinite angle you are getting. We cannot.
Okay, sir.
Infinite angle means you cannot. Okay. Karthik. Muhammad. Voice not clear. It is not coming. Voice not clear. No. Check it. Check the connection. Take the break. After the break, we'll discuss. Okay. Right. Next one. Last problem in this chapter. The Nyquist plots. Actually, Nyquist plots we didn't discuss, but there is a shortcut. That's why I'm discussing. The Nyquist plots or the frequency range or the frequency range 0 to infinity is shown in figure. The Nyquist plot or the frequency range 0 to infinity is shown in figure. Identify the closed loop distance stability. Come on. This is -1. Come on. Identify the closed loop distance stability. Simple shortcut is actually it belongs to the Nyquist plots, but simple shortcut is walk along the given direction. Walk along the given direction. Walk along the given direction. The right hand side of the right hand side of walking direction the right hand side of walking direction, the critical point should not exist. The right hand side of walking direction, the critical point, it will come in the Nyquist plot. What is the critical point? Critical point means -1 comma J0. Should not exist. So then the system is stable. Then the closed loop system is stable. Come on, check it. This is walking direction. For example, you are walking like this. This is the right hand side. Right hand side critical point not there. Check it. Right hand side. Is there -1? No. That means this system is stable. This method valid for all the system, minimum pace, non-minimum pace, everything it is valid. Just walk along the direction. Walk along the right hand side, critical point not there means it is stable. So along the direction you should walk. For example, here you are walking like this is the right. For walking means this is the right. This is the right. Right side this. Right. This is the right. For walking, this is the right. Here, this is the right. This is the right. That means -1 is not exist to the right hand side of walking direction. That means what? Closed loop system stable. Here, walk it. Come on, this is the right. -1 is there. Closed loop system unstable. Here, walk it. This is the right side. -1 is there. Closed loop system unstable. That's all. So like this, just walk along the given direction. Right hand side -1 not there means it is stable. -1 is there means it is unstable. That's all. Okay. This is the simple shortcut. It is valid for even minimum pace, non-minimum pace, everything it is valid. Okay, na? Right. No need to check the gain margin pace. Gain margin pace margin not valid. It is not a minimum pace. This is not a minimum pace. You should not check it. They don't ask calculate gain margin, pace margin for non-minimum pace system. You no need to worry. Any question comes on gain margin, pace margin, generally that is a minimum pace system only. Okay, na? They don't ask for non-minimum. If it is exactly -1 passing means marginal stable. Okay. If it is passing through -1, no doubt it is a marginal stable. No doubt. Yes, correct. Write it. Next, put the heading Nyquist plots. Nyquist plots. Purpose. To draw the frequency response of open loop transfer function. To draw the frequency response of open loop transfer function. G of S, H of S. Next. To find the closed loop system stability. To find the closed loop system stability. Next. To find the number of closed loop poles in the right hand side. To find the number of closed loop poles in the right of S plane. Next, to find the range of K value for system stability. To find the range of K value for closed loop system stability. Tomorrow onwards, class is 5 o'clock. Closed loop system stability. To find the gain margin, phase margin. To find gain margin, phase margin, gain crossover frequency and phase crossover frequency. Next, to find relative stability. This is the purpose of Nyquist plot. This is the purpose of Nyquist plot. Up to 10 not possible, man, because their employees, they will leave the academy. Okay. Right. Right. Okay. Yeah. See, the Nyquist stability criteria developed by using the mathematical principle actually. Nyquist stability criteria developed by using a mathematical principle known as principle of argument. Nyquist stability criteria. Nyquist stability criteria developed by using mathematical analysis, mathematical principle known as principle of argument. Principle of arguments. It is a mathematical concept that they are using in the what? Nyquist plots. Okay, na? So now, what is the principle of arguments? Principle of arguments. Principle of arguments. It states that if there are p poles and z zeros, if there are p poles, z zeros, enclosed, if there are p poles, z zeros are enclosed, p poles and z zeros, if there are p poles and z zeros are enclosed by the random selected closed path, by the random selected closed path, then the corresponding G of S, H of S plane, the corresponding G of S, H of S plane enclose the origin. with P minus Z times. Enclose the origin with P minus Z times. It states that if there are P poles and Z zeros are enclosed by the random selected closure path, then the corresponding G of S H of S plane encircles the origin with P minus Z times. That is N equal to P minus Z. N equal to P minus Z. N is number of encirclements about the origin. P is open loop poles. Z is open loop zeros. It will come. Now listen. So I will explain by taking the diagram how it is means. For example, now this is S plane. S plane. G of S, H of S plane. S plane and G of S, H of S plane. Now, for example, in the S plane, I'll take one pole. In the S plane, I'll take one pole. Or you take GH, for example. You take the GH, 1 minute. 1 minute, Bhaiya. For example, I'll consider right, listen. For example, listen all of you. G of S, H of S equal to take some term. S plus 1 by S plus 2. S plus 3 you take. For example, you consider. Then where are the poles and zeros? Tell. First, poles and zeros represented in S plane. So I'll represent the poles and zeros. 1 0 at origin, 1 pole at -2, 1 pole at -3. Then G of S, H of S plane is then randomly select one closed path. Randomly select the closed path. Randomly select the closed path. You can randomly select the closed path. Then what is the correspond? See, here what is n value? Tell this is random selected closed path. Calculate the n value here. N equal to what? P minus Z. What is P? How many poles enclosed in the path? How many zeros enclosed in the path? So how many poles enclosed? Only one pole enclosed. How many zeros enclosed? 0. That means n equal to what? 1. N equal to 1. This is S plane. Now draw the G of S, H of S plane. How to draw the G of S, H of S plane means? So the random selected closed path. Path is nothing but combination of many points like this. Path is nothing but combination of many points like this. Many points. At each and every point, you have to calculate the GH value. For example, this is minus 1.5. This is minus 1.5 minus J1. This is minus 1.5 minus J1.2 like this. So minus 1.6, for example, minus J1.2 something. At each and every point here is substitute S equal to minus 1.5. At each and every point, just replace S by minus 1.5. Then find the value that is called GH. You find the value that is called GH. That should be represented in GH plane. This is called real GH. This is called imaginary GH. that should be represented in G of S, H of S plane. For example, the value I consider 1 point, for example, 2, that means somewhere here 2, it should be represented. Similarly, second point you calculate, somewhere you will get here. Third point calculate, somewhere here you will get. And join all the points, then you will get the encirclements about the origin. If you join all the points, then you will get the encirclements about the origin. Encirclements about the origin. How many encirclements about the origin means n equal to p minus z. How many got it? 1. That means 1 encirclement about origin. Even if you draw a line, n equal to how much we are getting? 1 time touching. Only 1 time touching. That means n equal to 1. Both the n values should be same. Both the n values should be same. That is the condition. Both the n values should be same. Okay, na? Both the n value. Whatever the n value are getting for S plane, you should get the same n value for the GH plane. This is the principle of argument. For example, in case, listen, for example, in case, in the S plane, selected 2 zeros, for example. In the S plane, selected 2 zeros, for example. Listen. For example, 2 zeros. The random selected closed path includes the 2 zeros, for example. What happened in G of S, H of S plane? What happened G of S, H of S plane? So what happened G of S, H of S plane? Come on, bolo. Bolo, what happened? Come on. What is n value tell here? N is p minus z. P is 0. Z is minus 2. That means what you are getting? Minus 2. If you draw the GH plane, how many encirclements tell? 2 encirclements, because 2 zeros mean 2 encirclements. Number of encirclements n equal to what? P minus z, 2 encirclements. But if I draw a line here, if I draw a line from origin, what is the n value I am getting? Here 1 time intersecting, here 1 time intersecting. What is the n value I am getting? 2. But I should get the minus 2. How can I get the negative sign? So we should get the same sign. Whatever the n value are getting to the S plane, we should get the same n value for the GH plane. So, but here minus 2 is there, here plus 2 is there. I should get same. To get the same n value, they selected the direction. To get the same n value, they selected the direction. So, for example, they selected the direction. Listen, I'll select the direction here, for example, clockwise. Random selected closed path direction, I'll select the clockwise. We'll select the clockwise. I'll write the conditions here itself. I'll select the clockwise. So if the pole is enclosed, if pole is enclosed, then change the direction. Just assumptions, these are assumptions. Then change the direction. Change the direction. If 0 enclosed, if 0 is enclosed, then no change in direction. No, this is completely our assumption. These assumptions we should make that both the n values are same. Whatever the n value are getting for the S plane, you should get the same n value. So I assumed pole means change in direction. 0 means no change in direction. According to Nagrat and Gopal textbook, I selected these assumptions. Even competitive exams also, they are following this. So you follow the same notation. So here clockwise direction. So that means what is enclosed? Pole. So change the direction. That means here it become anti-clockwise. Change the direction means it become anti-clockwise. What is the n value I got? 1 minus 0, 1. That means I got plus 1. I got plus 1. Here also I should get the plus 1. Here also I should get the plus 1. Anti-clockwise, and I should assume a sign for anti-clockwise is positive sign, I should assume. Clockwise means I assume the negative sign. So we should assign a sign for anti-clockwise. Here, what is the direction? Anti-clockwise plus 1 time touching 1. So n equal to plus 1. Anti-clockwise positive 1 time touching. So 1. So n equal to plus 1. Both the n values are same. For example, come here. So I selected random selected closed path is clockwise. N equal to what I got? Minus 2. Now enclosed 0. No change in direction. That means here also clockwise only. No change in direction. That means here also clockwise only. What is the answer? Tell. Clockwise means what is the answer? Here clockwise negative 1 time touching 1. Here also clockwise negative 1 time touching 1. So what is the n value? Tell. What is the n value? What is the n value? N equal to what? Minus 2. N equal to minus 2. Both the n values are same. Both the n values should be same. For example, random selected closed path. For example, random selected closed path enclosed 3 poles and 1 0. Random selected closed path enclosed 3 poles and 1 0. What is corresponding GH plane? Corresponding GH plane you tell. How many encirclements you will get? Tell. P minus Z. N equal to P minus Z. P is 3, Z is 1. So that means 2 encirclement plus 2. Now I should draw the 2 encirclements like this. 2 encirclements I should draw. What is the direction? Tell. Poles are more. That means the direction is anti-clockwise. The direction is anti-clockwise like this. The direction is anti-clockwise like this. Like this. Then draw the line and check it value. This is plus 1. This is plus 1 anti-clockwise. N equal to what? Plus 2. Both the n values are same. Both the n values are same. Both the n values are same. Okay. Okay. Next. In case, for example, enclosed 1 pole 1 0 in the S plane. Enclosed 1 pole 1 0. Enclosed 1 pole and 1 0 in the random selected closed path. Enclosed 1 pole and 1 0. Then what is GH plane? Tell. Are not enclosed any pole or any 0 like this is there. Not enclosed any pole or any 0. Not enclosed any pole or any 0. Not enclosed. Then what is the GH plane? Bolo, what is GH plane? So that what happened? There is no encirclements about the origin. There is no encirclements about the origin. So n equal to 0. Here also what? N equal to 0. Here also what? N equal to 1 minus 1 is 0. So this is the what? Principle of argument concept. But how it is useful for the stability? Anybody? How this principle of argument concept is useful for the stability? Anybody? The wrong direction I taken. This is anti-clock. Oh, here clockwise, same direction. Sorry. 0, na? 0 means no change in direction. 0 means no change in direction. No change in direction means what? Clockwise only. Here clockwise. Very good. Thank you. So clockwise direction like this. Clockwise minus 1. Clockwise. This is clockwise. Here anti-clockwise. Here clockwise. Right. Next. Okay. This is the what? Principle of argument. How this principle of argument concept is useful? Anybody? How this principle of argument concept is useful? How this is useful for Nyquist stability criteria? How the principle of argument concept is useful for Nyquist stability criteria? Listen. What Nyquist did is, this principle of argument concept is applied to the total write-off of the S-plane. The principle of argument concept is applied to the total write-off of the S-plane. Principle of argument concept. Principle of arguments concept applied to the total write-off of the S-plane. Total write-off of S-plane. Total write-off of the S-plane. Total write-off S-plane. Principle of argument concept applied to the total write-off S-plane. By selecting total write-off of the S-plane, by selecting the principle of argument concept applied to total write-off of the S-plane, by selecting with a radius of infinity, by selecting a semicircle, with a radius of infinity, Now what is doing is selected complete right side with a radius of infinity. Complete right, total write-off of S-plane is selected. The selected total write-off of the S-plane. The selected total write-off of the S-plane. Total write-off S-plane with a radius of infinity. With a radius of infinity. Radius of infinity is called Nyquist contour. Is called Nyquist contour. Is called Nyquist contour. Is called Nyquist contour. Nyquist contour. The selected total write-off of the S-plane with the radius of infinity is called Nyquist contour. I will draw the Nyquist contour. Listen here. That's all. So here, complete right side selected as a closed path. Complete right side selected as a closed path. Complete right side selected as a closed path like this. Right, complete right side. This is the radius of infinity. This is plus j infinity. This is minus j infinity. So this is 0 with the direction of clockwise. We selected random. This is a random selected closed path. That random selected closed path applied to the total write-off of the S-plane. The random principle of argument concept applied to the total write-off of the S-plane. And means that this random selected closed path we applied to the complete write-off of the S-plane as a closed path. So this is called Nyquist contour. This is called Nyquist contour. This is called Nyquist contour. ठीक है ना? This is called Nyquist contour. ठीक है ना? So The complete write-off of the S-plane selected as a closed path like this. This is called the Nyquist contour. Okay. Then what is N here in the Nyquist contour? So Nyquist contour is applied to principle of argument concept applied to complete right eye. Principle of argument concept applied to complete right side. So what is N, what is P, what is Z here? Tell. N is called number of encirclements about origin. N is called number of encirclements. Number of encirclements about origin. Number of encirclements about origin. N is called number of encirclements about origin. P is called open loop transfer function poles in the right of S plane. Open loop transfer function means G of S, H of S. Poles in the right of S plane. G of S, H of S, poles in the right of S plane. Right side come. Always consider only right side. We never, Nyquist stability criteria deals with only right side poles. We never talk about the left side. We'll talk about only right. Why? Because doing the right hand side analysis is very easy compared to left hand side analysis. See, if 1,000 poles are there, more number of poles where exist in the left hand side. So right hand side, very less number of the poles is there. So identifying number of poles in the right is easy. That's why Nyquist did the what? The right of S-plane analysis. Z is called open loop transfer function zeros. Open loop transfer function G of S, H of S zeros. Zeros in the right of S-plane. Zeros in the right of S-plane. Right of S-plane. Z is called open loop transfer function zeros in the right of S-plane. N is called open loop transfer function poles in the right of S-plane. So N is number of encirclements about origin. Origin means 0, 0. Origin. See here, two concepts you will get here. About origin you will get as well as about -1 also will get it. About -1 also will get. Okay, na? Okay. Right, it will come. This is not a Nyquist plot, it is a Nyquist contour. So from Nyquist contour, that means this is like S-plane. This is S-plane. We have to draw the GH plane. By do this, you have to draw the GH plane. That GH plane is called Nyquist plot. From the Nyquist plot, we will find the stability. It will come. So N is called number of encirclement about origin. P is called open loop poles right. Z is called open loop zeros right. You should be very much careful about calculation of encirclements. Either encirclements you are taking about origin or about -1. That is should carefully observe. So very rare cases in the exam they are asking encirclement about origin. Very rare cases they are asking encirclements about origin. Whenever encirclements about origin they ask, P is called open loop poles right, Z is called open loop zeros right. In case ask encirclements about -1, then P and Z are going to be changed. Then P and Z are going to be changed. -1 means P and Z changes. Okay, na? Once they asked a question like this, find the number of encirclements about origin. Find the number of encirclements about origin. Origin in the GH plane. In the G of S, H of S plane. Plane to the given system. To the given system. That is G of S, H of S equal to 1 by S minus 1, S plus 2, S plus 3. Come on, do it. 1 by s minus 1, s plus 2, s plus 3. Come on. So how many poles right here? Tell. One pole right. Simply what is the formula? N equal to P minus Z. What is P? Open loop pole right. How many poles right? One pole right. How many zeros right? No zeros right. So that means N equal to plus 1. That means one encirclement. One encirclement about origin. So whenever they ask about origin, P and Z are open loop poles and zeros. Be remember. Okay, na? Next, pole zero configuration. Next, pole zero configuration. Pole zero configuration. Okay, na? Encirclements always will find only in the GH plane only. Encirclements will find only in the GH plane, not in the what S plane. Okay, na? Right. Next. Next. Pole zero configuration. By using that, we got the statement for the what? Nyquist stability criteria. Pole zero configuration. Pole zero configuration. Right. Open loop transfer function. Open loop transfer function. G of S, H of S equal to K into N of S by D of S. So this is equation number 1. Open loop transfer function G of S, H of S equal to K into N of S by D of S. Then closed loop transfer function. C of S by R of S equal to G of S by 1 plus G of S H of S. Closed loop transfer function C of S by R of S equal to G of S by 1 plus G of S H of S. Then C of S by R of S equal to, substitute G of S H of S, what I will get? 1 plus K N of S by D of S. Then closed loop transfer function C of S by R of S equal to G of S D of S divided by D of S plus K N of S. This is what closed loop transfer function. This is equation number 2. Next, closed loop stability given by characteristic equation. Closed loop stability is given by characteristic equation. What is that characteristic equation? Means you selected Q of S equal to 1 plus G of S H of S. Q of S equal to characteristic equation. Q of S equal to 1 plus G of S H of S. 1 plus G of S H of S. Okay, na? Now substitute G of S H of S. Q of S equal to 1 plus K N of S by D of S. Then Q of S equal to characteristic equation. So what I am getting? D of S plus K N of S. He selected characteristic equation. D of S plus K N of S by D of S. This is equation number 3. Now we have to compare equation because we are going to draw a GH plane. From the GH plane, you have to find the closed loop stability. That's why this pole zero configuration. So now listen. Now listen. Equation 3 and 1 compare. Compare equation 3 and 1. Equation 3 and 1. Compare equation 3 and 1. What are same in 3 and 1? Here D of S, here D of S is same. What is D of S here? Poles of characteristic equation. Poles of characteristic equation is equal to what? What is here D of S? Open loop transfer function poles. Open loop transfer function poles. Poles of characteristic equation equal to open loop transfer function poles. Poles of characteristic equation equal to open loop transfer function poles. Next, compare equation 3 and 2. Compare equation 3 and 2. 3 and 2. Compare equation 3 and 2. If you compare 3 and 2, what are same tell? In 3 numerator term and in 2 denominator term. Here numerator is called zeros of characteristic equation. Zeros of characteristic equation is equal to closed loop transfer function poles. Closed loop transfer function poles. Zeros of characteristic equation equal to closed loop transfer function poles. Closed loop transfer function poles. Zeros of characteristic equation equal to closed loop transfer function poles. Poles of characteristic equation equal to what? Open loop transfer function poles. Now what is n tell? N equal to P minus Z. I'll write in the next page better. N equal to P minus Z. N equal to P minus Z. What is N tell? What is N? Number of encirclements. Number of encirclements about critical point. Number of encirclements about critical point. Number of encirclements about critical point. N is called number of encirclements about critical point means what? -1 comma J0, because we want closed loop stability. We don't want GH stability. We want one GH stability directly we can identify. GH stability directly we can identify by looking at what? GH poles and zeros. GH poles and zeros. For example, how they will give GH like S plus 1 by S plus 2, S plus 3. Like this, if you give, directly we can identify open loop stability. But which stability we want? Closed loop stability. That is 1 plus GH stability. You want 1 plus GH stability, we require to take encirclements about -1. We require to take encirclements about -1 to get the closed loop stability. What is P? Poles of characteristic equation. Poles of characteristic equation, which are nothing. Poles of characteristic equation in the right of S plane, not left side, right of S plane. Poles of characteristic equation in the right of S plane, which are nothing but what? What is the poles of characteristic equation? Check it. Open loop transfer function poles in the right of S plane, which are nothing but open loop transfer function poles in the right of S plane. P is nothing but open loop transfer function poles in the right of S plane. In the right of S plane. Open loop transfer function poles in the right of S plane. What is Z tell? Z is called what? Zeros of characteristic equation. Z is called zeros of characteristic equation. Zeros of characteristic equation in the right of S plane. In the right of S plane. Zeros of characteristic equation in the right of S plane. Z is called zeros of characteristic equation in the right of S plane. What are the zeros of characteristic equation? Dekho here. Zeros of characteristic equation equal to what? Closed loop transfer function pole. So zeros of transfer characteristic equation nothing but closed loop transfer function poles in the right of S plane. In the right of S plane. In the right of S plane. Closed loop transfer function poles in the right of S plane. So what is P? Open loop poles right. P is open loop poles right. What is Z? Closed loop poles right. Z is nothing but closed loop poles right. P is nothing but open loop poles right. N is nothing but number of encirclement about the critical point. Why it is critical point means to get closed loop system stability. To get closed loop system stability, we require to consider the encirclements about -1. To get closed loop stability, to get closed loop stability, to get closed loop stability, the encirclements should be considered about -1. The encirclements should be considered about -1. Encirclement should be considered about -1. -1 comma J0. We remember this. ठीक है ना? To get closed loop stability, the encirclement should be considered about -1. That's all. So next, when the closed loop system is stable, tell what is the condition for closed loop stability? Closed loop stability. When the closed loop system stable, tell, come on. There should not be any closed loop pole in the right hand side. Listen by all of you, listen. When the closed loop system stable means, closed loop system stable means there should not be any closed loop pole in the right hand side. That means closed loop poles in the right hand side, how many? 0. Closed loop poles in the right, this is right only, na? In the RH should be 0. Closed loop poles are nothing but what? Zeros of characteristic equation. Zeros of closed loop poles are nothing but what? Closed loop poles are nothing but zeros of characteristic equation in the right, in right, how much? 0. That means Z equal to 0. Z equal to 0. Once Z equal to 0, what happens? Z0 substitute here, N equal to P. Whenever N equal to P, then the closed loop system becomes stable. N equal to P means closed loop system is stable. N equal to P means default Z0. Z0 means closed loop system stable. N equal to P means closed loop system becomes the stable. This N equal to P only given a Nyquist stability criteria statement. The Nyquist stability criteria statement given by N equal to P only. N equal to P. What is N? Now tell, what is the Nyquist stability criteria? Nyquist stability criteria. Nyquist stability criteria. Statement you tell, come on, statement. What is the statement? Come on. It states that what I told, N equal to P. What is N? What is P? That's all, enough. It states that, come on, the number of encirclements, sorry, the number of encirclements about critical point the number of encirclements about critical point, that is -1 comma J0. The number of encirclements about the critical point, that is -1 J0, should be equal to poles of characteristic equation. should be equal to poles of characteristic equation, which are nothing but open loop transfer function poles in the right half of the S-plane. In the right half of the S-plane. So that is n equal to P. N equal to P means closed loop system stable. N is called number of encirclements about the critical point should be equal to poles of characteristic equation, which are nothing but open loop transfer function poles in the right of the S-plane. That's all. It is a what? Nyquist stability criteria statement. Okay. Next, we have to solve the problems. Region means we are drawing the GH plane. Na? Nyquist plot is a GH plane. G of S, H of S plane. G of S, H of S plane. Available plane is GH plane. Yeah. Available plane is GH plane. Available GH plane. But required what? Required plane is what? 1 plus GH plane, because we want closed loop stability. Na? 1 plus GH plane we want. Required 1 plus GH. Available GH. Then how can you get the stability? We cannot draw 1 plus GH plane. It is not possible to draw 1 plus GH plane because we don't know the location of what? We don't know the location of 1 plus GH poles and zeros. So that's why we cannot draw 1 plus GH plane. So available only GH plane. Then what they did? If in case you are able to draw 1 plus GH plane, we might have taken encirclements about origin. Then what they did? Because it is available GH plane, instead of taking 1 plus GH equal to 0, GH equal to what? Minus 1 plus J0. That means instead of taking encirclements about origin, they are taking about minus 1. Once you take about minus 1, automatically will get the closed loop system stability. Once you will get the encirclements about the minus 1, automatically will get the what? Closed loop system stability. Same thing I told, na? Z is zeros of characteristic equation in the right of S plane, which are called closed loop poles in the right of S plane. What I written? Poles of characteristic equation is open loop, correct only. What I written here? Zeros of characteristic equation is closed loop, correct only written, na? Zeros of characteristic equation called closed loop transfer function poles, correct only. But closed loop stability n equal to P. P is called what? Poles of characteristic equation, not zeros. Poles of character, which are called open loop transfer function poles in the right of the S plane. Okay. Next I have to solve the problem. The problem, first problem, I will try to solve by the procedure. It takes little bit time. And the remaining problems will go by shortcut. Tomorrow I'll do it because first problem it takes near around 45 minutes. I think more than that. Tomorrow I'll discuss. I'll close here. If you have any doubt, you can ask. Okay. Right. Come on, ask the doubts. If you have doubts, you can ask. Akansh Lal.
Hello.
Tell.
Sir, here in Nyquist plot, we are talking about the right-hand poles and all. But, sir, in the Nyquist...
I told na Nyquist stability criteria deals with completely right side because Nyquist contour is completely right, na?
Yes, sir. Yes, sir.
Well, then what is your doubt?
Sir, my doubt is that earlier we said that right-hand poles are making unstable, so we...
Not only, if no pole right, what is the condition I told here? Check it.
Sir, so earlier also...
Here, we'll check it. Is there any pole in the right?
Yes, sir.
No pole right means where are the poles?
On the left, then the
That's
system
all.
is stable. Yes, sir.
Then
yes,
that's all. That only
yes,
we are checking.
Means we have checked earlier also. So why?
Where we'll check it?
So in RH and all, means we check now whether it is in right or left by changing
RH
this.
criteria, we are able to find right to left to imaginary. Here you cannot find like that. Just we can check right side any pole is there or not. That's all. Right
Yeah.
side not there means what happened?
Yes, sir, this I understood. I'm just asking that in the
This
RH
is
also.
completely right side analysis. RH also it gives.
Yes, sir. So then why we
RH also it
need?
gives.
So that was simpler than why we need a Nyquist plot, because there also we could know that how many poles are there on the right.
Then exponential terms, higher order systems,
Okay.
then Nyquist plot will be the better. Can you find exponential term exact stability?
No, sir.
Can you find exponential term exact stability in the by using polar plots? Not
Okay,
possible.
okay.
Only Nyquist only possible.
Okay, okay, sir. Sir, and while teaching, like in 6F, page number 6F. So while drawing polar plot and all, yes, sir, here omega is equal to 1. The graph is crossing the minus 180-degree line.
Yes, it is crossing. Check it.
Yes, sir, it's crossing. So I am asking that every time omega will be equal to 1 radian per second.
No. Because I selected 1, 2, 3. At
Okay,
one
okay.
only positive value, negative values, both are matching. That's why 1. If you take it different values here, 2, 4, 6, it will be different value. How it will be 1 always?
Okay, okay. Sir, and one more.
Tell. Tell.
Yes, sir, yes, sir. Sir, one question was there. Breakaway point on root locus diagram exists anywhere in the plane. Means on the when the root locus will be in complex point also, then also we can find breakaway
I didn't
point.
get. One
Sir,
more time.
So in volume 2, there was one question: breakaway point on the root locus diagram exist, and the answer was anywhere in the plane.
Anywhere in the
plane, S plane.
No, wrong.
So on the real axis only, no?
No, it is real, maybe complex. But
So
on the root locus branch only. I
Okay,
told
yes.
na complex breakpoint centroid equal to real part of the complex pole.
Yes,
Complex
sir.
breakpoints exist. One problem also solved. Check it.
Okay, sir.
Okay.
Sir, and marginal stability is only for a closed loop transfer function, or it can also be for open loop?
If open loop poles directly we can identify. Now open loop pole at origin or open loop poles repeat on imaginary, then open loop system marginal stable.
Okay. So last doubt.
Tell.
So there was one IAS question. The angle between two adjacent asymptotes in the root locus diagram.
Angle between two asymptotes is what? Plus or minus? I told already, na? Plus or minus 180 by n, na?
Yes, sir. Yes, sir.
But that is because of plus or minus 180 by n.
Yes,
What is
sir.
the correct question they asked?
So the angle between two adjacent asymptotes in the root locus diagram.
Plus or minus 180 by n. That plus or minus not there, then you have to take 360 by n.
So it was 360 by poles minus 0.
N is called P minus Z only, na?
Okay, yes. Thank you.
Okay. Right, Abdul.
సార్ నాకు అది సర్కిల్ ఎన్క్లోజ్ అని అట్ ఆరిజిన్ చెప్పారు కదా సార్, నైక్లోస్ట్ ప్రిన్సిపల్ ఆఫ్ ఆర్గ్యుమెంట్స్, అది డయాగ్రామ్ ఒకసారి చేయండి సార్. ప్రిన్సిపల్ ఆఫ్ ఆర్గ్యుమెంట్స్ స్టార్టింగ్ 4 డయాగ్రామ్స్.
Page number you remember, na?
22 అనుకుంటా సార్.
ఇదేనా?
ఇది కాదు సార్, స్టార్టింగ్ ఫస్ట్.
Tell.
బ్యాక్ ఫస్ట్ 20 సార్. ఇక్కడ ఇది ఎలా తీసుకున్నారు సార్? ఇది
random. I told na random means what? We can select anyway.
అంటే ఇది అర్థం కాలేదు. ఇఫ్ పోల్ ఇస్ ఎన్క్లోజ్డ్ అండ్ చేంజ్ ద డైరెక్షన్ అంటే పోల్ చేంజ్ అయితే అంటే
That is
డైరెక్షన్
assumptions. These are completely assumptions. I told already.
assumptions. Okay.
You should take assumptions such that both the n values should be same. This n value, this n value same.
Okay. మళ్ళీ నెక్స్ట్ పేజ్ వెళ్ళండి సార్ 21. హలో సార్ ఇప్పుడు ఇది ఎలా తీసుకున్నారు సార్ అంటే ఇది క్లాక్ వైజ్ యాంటీ క్లాక్ వైజ్
Clockwise. Assumptions you remember. What are the assumptions? Tell. Pole means change the direction. Zero means
డోంట్ చేంజ్ ద డైరెక్షన్.
here pole enclosed here pole change the direction clockwise to anti-clockwise. Here what is enclosed?
0.
Then what is the direction? Change or not? No change.
డైరెక్షన్ చేంజ్.
No change. Read here. Read here.
Okay.
Zero.
Okay,
No
okay.
change in direction.
ఓకే ఓకే ఓకే
ఓకేనా?
అర్థం.
Krishna Vamshidhar.
Hello, sir.
Tell.
Sir, one doubt, sir. Like one clarification in the 15F.
Which page?
15F, sir. 15.
Tell.
Sir, here we should take the angle in the clockwise, no, sir?
Always.
Always. Okay, sir. Just that clarification only, sir.
Okay,
Thank you.
okay, okay. Agarwal. Agarwal. Satkar Agarwal.
Hello, sir.
Tell.
Sir, my doubt is on slide number 8.
Huh? 8.
8. Slide. Sir, in this, how phase angle is calculated?
I told in the root locus that this is which way?
No, sir. 180 plus tan inverse omega. How it is?
That only I told in the root locus very clearly. In which region that point lies? This is negative real. This is negative imaginary. What is this region? Third region. What is the angle up to this? 180. More than 180 means 180 plus theta.
Okay.
Theta is called tan inverse of imaginary part by real part.
Okay, sir. Thank you, sir.
You refer once root locus. I discussed for 4 coordinates angles there.
Okay, sir.
Okay now. Any more? Any more doubts? Agarwal, completed now? Okay, right.